This lecture is on solving systems of linear equations by addition/elimination in matrices. First of all, let's look at how you solve a system by addition/elimination. Here's a system. A system consists of two or more linear equations. So here we have the equation 3x plus 5y equals 1 and negative 4x plus 6y equals negative 14. I want to eliminate the x's. That's why we call it the elimination method. Then, in order to eliminate the x's, I have to add two equations together. So I try to multiply both equations by a number. That number will allow me to add two equations together to eliminate the x's. So I decided to multiply the first equation by negative 4 and the second equation by negative 3. So I multiply the first equation by negative 4, and as you can see, I got negative 12x minus 20y equals negative 4. That's what I have here. Negative 12x minus 20y equals negative 4. I multiply the second equation, E2, which is the second equation. The first equation is E1. I multiply the second equation by negative 3. That gave me positive 12x, and you can see how they will cancel when I add them together. One is a negative 12x, the other one is a positive 12x. So when I add those together, I get 0. And then negative 3 times 6 will give me negative 18, and then negative 3 times negative 14 will give me 42. And after I multiply, then I add the two equations together. And I've done that in the next step. You can see that the x's cancel, so I don't have anything here. I just leave that blank. And I have negative 38y equals 38. And then I divide both sides by, and this is equation 3. Equation 3 is negative 38y equals 38. Then I divide both sides by negative 38, as you can see there, and that gives me y equals 1. Once you get the value for y, you have to substitute that back into one of the original equations. I substituted it back into the first equation. The first equation was 3x plus 5y equals 1. I substituted the negative 1 for y. I simplified. I added a positive 5 to both sides. They gave me 3x equals 6, and then I divided both sides by 3. I got x equals 2. So that would be my solution. My solution, I can write it as x equals 2, y equals negative 1, or I can write it as an ordered pair, 2, negative 1. Now, there's one other thing you have to look out for. You have to look out for disappearing variables. So we call that the disappearance of the variables. If you're trying to solve a system and the variables disappear, you have to look at your statement that you have, and you have to ask yourself, is it true or false? If it's true, the solution to the problem is all real numbers. That means that any real number you put in that problem will work. If the statement is false, if the variables disappear and the statement is false, that means there's no solution to the problem. Once again, this is how you solve a system using the addition/elimination method. You have two problems for homework that you have to solve using this system. On page 393, you want to do problem 37 and 39. And you can play this tape as you do the problem to see if you're doing the problem correctly. All right, let's talk about using matrices to solve systems of linear equations. The process is as indicated here, and this is a transition from the method of addition/elimination to the method of using matrices to solve systems. So we start by solving the system by using the addition/elimination method. So you do that first. Even though you're using the matrix method, you solve it by using the addition/elimination method because you want to see the connection between those two. And this is a transition from one method to the other. All right, so you write equation 1 and equation 2 with numbers only. So we have a system here. The system is the same system that we just finished solving. 3x plus 5y equals 1. Negative 4x plus 6y equals negative 14. But now we just write the numbers, and that's our first matrix. We only need 2 matrices in order to solve the system using matrices. The first matrix just consists of the numbers, no variables. You just put the 3, the 5, and the 1, and then the negative 4, the 6, and the negative 14. And that's what I've done here. Just the numbers. That's the matrix. 3, 5, 1, negative 4, 6, negative 14. That's the first matrix. And then in the second matrix, you write the first row the same as it is in the first matrix. The first row, you have 3, 5, 1. And the second matrix, you have 3, 5, 1. Now, the second row in the second matrix really is the equation that you got after you added the 2 equations together. If we go back and look over here at what we did, after we added those 2 equations together, we got negative 38y equals 38. That's the second row, but we only use the numbers. And since we don't have any x's, we put a 0 in the x place. So we're going to have 0, negative 38, 38 in the second row of the matrix. So that's what we have here. In the second row of the second matrix, we have 0, negative 38, positive 38. And notice here that instead of using E, we use R. We have negative 4R1 plus negative 3R2. So back in the previous method, we use E for equations, but we're using R for row when you're dealing with matrices. So you have to put this little formula above the second matrix. So that's all you have to do as far as the matrices are concerned. And this is the method of solving a system by using matrices, and I hope you can see the connection between the addition/elimination method and the matrix methods. But now, the second row, you have to turn it back into an equation. And this column represents y, this column represents x. So the negative 38 would really be negative 38y. So you're using the matrix method because you're using the matrices. But the last row, you turn it back into an equation and you solve it. So we have negative 38y equals 38. We divide both sides by negative 38, the same way we did previously when we solved it using the addition and the elimination method, and we still get y equals negative 1. Now, when you're doing the matrices method, you have to do the same thing you did when you were doing the addition/elimination method. You have to substitute the negative 1 back into one of the original equations and then solve for x. So that's what we've done here. We substituted the negative 1 in the first equation, once again, for y, and then we solved it for x. And of course, we got the same answer, x equals 2. So these 2 methods, you can let one be a cross-check against the other. That's what you can do for these 2 methods here. The matrix method and the addition/elimination method. You can do it one way, see what answer you got, then do it the other way, see what answer you got. So once you get, you substitute it back in, that gives you y, and you can express your answer the same way you did before. Now, here's an example that you can try, see if you can work that out. Now, for the homework on the matrix method, the homework on using matrices to solve linear systems, you want to do the same two problems that you did using the addition/elimination method. But this time, you want to use the method of matrices. You want to solve the system by using the matrices, which means you have to write just the numbers in the first matrix. And then when you go to the second matrix, the first row is the same as in the first matrix. But the second row comes from adding the two equations together. When you multiply the two equations by numbers, and then you added the two equations together. Just like back in this problem, we multiplied the first equation by -4. We multiplied the second equation by -3. And then we added the two equations together. You see, after we added the two equations together, we got -38y equals 38. So that gives you the second row in your matrix after you add the two equations together, after you eliminated the x. And notice that you don't have any x's, so on the matrix, you put a 0 in the place of the x. And then, of course, you have to write the equation. The second row is the equation that you have to write, and then you have to solve it, and that gives you y. And after you get y, you plug it back into the first equation, and you solve it for x. And there you have your solution. You have x equals 2, y equals -1. Have a great day. Bye now.